Boreal forests are the world's largest land biome. These coniferous forests cover much of Russia, Canada, and Alaska. They are found primarily between 50 and 65 degrees north latitude, and they are characterized by a thin layer of unfrozen soil. These forests are home to caribou, moose, wolves, loons, wood frogs, and many other species absent or rare elsewhere. For a millennium, they have been fixing carbon from the atmosphere. Alas, those days are behind us. The headline of an article at phys.org is, "After millennia as a CO2 sink, more than one-third of Arctic-Boreal region is now a source." The article was published January 21st, 2025. Here's the lead. Quote, "After millennia as a carbon deep freezer for the planet, regional hotspots and increasingly frequent wildfires in the northern latitudes have nearly canceled out that critical storage capacity in the permafrost region, according to a study published in Nature Climate Change." End quote. The next three paragraphs of the article at phys.org reveal the magnitude of this transition. Quote, "An international team led by Woodwell Climate Research Center found that a third, 34%, of the Arctic Boreal zone, the treeless tundra, boreal forests, and wetlands that make up Earth's northern latitudes, is now a source of carbon to the atmosphere. That balance sheet is made up of carbon dioxide, uptake from plant photosynthesis, and CO2 released into the atmosphere through microbial and plant respiration. When emissions from fire were added, the percentage grew to 40%. The findings represent the most current and comprehensive assessment of carbon fluxes in the Arctic Boreal zone to date. Drawing on a library of CO2 data 4 times as large as earlier upscaling efforts gathered from 200 study sites from 1990 to 2020, the analysis captures both year-round dynamics and important recent shifts in climate and northern fire regimes that have altered the carbon balance in the north." End quote. Further into the article at phys.org, we find this information. Quote, "The latest findings add to a growing ensemble of recent studies that show how carbon budgets in the north are changing after the region's historical role as a sink. While this study focused on CO2 fluxes on land, other recent results that counted CO2 and methane, emissions from lakes, rivers, and wetlands, also found the permafrost region to be a carbon source." End quote. As I'm sure you are aware, this is very inconvenient. Although our rapidly heating Earth is causing rapid greening in some areas, the overall balance is one of increased respiration, not increased photosynthesis. The amount of carbon dioxide released into the atmosphere increases as warming accelerates. As expressed in the phys.org article, quote, "While 49% of the Arctic Boreal zone region experienced greening, in which longer growing seasons and more vegetation means that more carbon can be photosynthesized and stored, only 12% of those greening pixels on the map showed an annual increasing net uptake of CO2. End quote. In other words, yet another self-reinforcing feedback loop has been identified. As Earth warms, more carbon dioxide is released from the world's largest land biome. This carbon dioxide traps more long-wave radiation, thus causing additional warming. I now turn to the peer-reviewed paper mentioned in the phys.org article. Published in Nature Climate Change on February 28, 2025, the paper is titled "Ocean Extremes as a Stress Test for Marine Ecosystems and Society." The peer-reviewed paper was created by 13 scholars. I will read the short abstract. Quote, "In 2023 to 2024, widespread marine heat waves associated with record ocean temperatures impacted ocean processes, marine species, ecosystems, and coastal communities with economic consequences. Despite warnings, interventions were limited. Proactive strategies are needed for inevitable future events." End quote. I'm not surprised, quote, "widespread marine heat waves associated with record ocean temperatures," end quote, "have led to numerous environmental and economic consequences. This is the expected result of an overheated global ocean. It is unclear to me why, quote, "proactive strategies are needed for inevitable future events," end quote. After all, these future events are inevitable, by definition. I now turn to a second peer-reviewed paper in Nature Climate Change. Published on January 21st, 2025, this open access paper was created by 63 scholars. It is titled, "Wildfires Offset the Increasing but Spatially Heterogeneous Arctic-Boreal CO2 Uptake." The abstract is followed by the main section, which cites considerable peer-reviewed evidence as it includes this information. Quote, "Estimating the terrestrial net ecosystem CO2 exchange of the Arctic-Boreal zone poses a major challenge due to complex biogeophysical dynamics and a limited network of field measurements. As a result, models show a wide range of CO2 budgets from substantial net atmospheric sinks to moderate atmospheric sources, a concerning discrepancy as northern permafrost soils hold nearly half of the global soil organic carbon stocks. The release of this soil carbon to the atmosphere as CO2 could considerably exacerbate climate change. There is thus an urgent need to improve CO2 budget estimates across the Arctic-Boreal zone." The rapid climate change of the Arctic-Boreal zone makes this discrepancy even more critical. Increasing air and soil temperatures in both summer and non-summer seasons are causing changes in the CO2 budget that remain poorly understood. Furthermore, it is not known how the widespread but spatially heterogeneous increase in vegetation productivity and greening impacts the annual CO2 balance, although links to enhanced CO2 sinks during the spring-summer period have been found. Some of the enhanced uptake might be offset by CO2 losses associated with increasing non-summer season respiration, vegetation dieback, and the escalating frequency and intensity of disturbances such as abrupt permafrost thaw, droughts and fires, further complicating the understanding of Arctic-Boreal zone carbon dynamics and climate feedbacks. Current evidence on recent Arctic-Boreal zone CO2 budget trends and their main drivers is limited to few in situ data-driven synthesis and modeling studies without a regional perspective on where and why CO2 budgets are changing. These studies have focused primarily on ecosystem CO2 fluxes, that is, not incorporating fire emissions, coarse annual or seasonal CO2 fluxes, that is, overlooking the intra-annual dynamics, and spatial patterns in CO2 fluxes with data from only 1 to 2 decades. Most importantly, earlier studies have not extended into the 2020s, a period when warming has further accelerated and fires have burned large areas. We thus lack a comprehensive understanding of the regional and seasonal patterns in recent ecosystem CO2 fluxes, including fire emissions, their multi-decadal trends, and the links to changing environmental conditions across the Arctic-Boreal zone. Here we address this knowledge gap using an Arctic-Boreal zone CO2 flux dataset that includes monthly terrestrial photosynthesis, ecosystem respiration, and net ecosystem CO2 exchange data from 200 terrestrial eddy covariance and flux chamber sites. This dataset is at least 4 times larger than ones used in earlier upscaling efforts and covers a longer period, with data extending to 2020. End quote. The bottom line, ironically, appears in the final paragraph of the discussion section. Quote, "In summary, our study reveals distinct spatial and temporal patterns in CO2 budgets across the Arctic-Boreal zone and underscores the importance of 3 decades worth of data. Relatively robust spatial patterns can be seen, such as the Alaskan CO2 sources and southern Eurasian boreal sinks, while the temporal trends remain more uncertain. While CO2 fluxes can be relatively well modeled using machine learning and existing gridded data sets, gaps persist, such as the incomplete characterization of fire, thermokarst, and harvesting disturbances and their links to ecosystem CO2 fluxes, the lack of accurate predictors describing soil moisture, and the need to quantify landscape's heterogeneity and carbon dynamics at even higher spatial and temporal resolutions. Sustaining long-term sites is crucial to accurately tracking trends in Arctic-Boreal zone CO2 balance, while establishing new year-round sites in data-poor areas such as Siberia and the Canadian Arctic is vital to filling knowledge gaps and enhancing our understanding of carbon dynamics." End quote. This relatively long video reveals 3 key pieces of information. Carbon being released from a huge forested area is poorly understood. Another self-reinforcing feedback loop has been identified, and wildfires indicate the carbon balance in the Arctic Boreal zone is worse than previously documented. In other words, the more we look, the worse the climate emergency appears. Color me shocked.